Consider the function f of x is equal to x square. Complete the table of values and sketch a graph for this function. So if f of x is equal to x square, it would be 9, 4, 1, 0, 1, 4, 9. Okay, now complete the table of the values and sketch a graph for this function. So for minus 3, it would be plus 9, minus 2, it would be plus 4, minus 1, it would be plus 1, 0, 1 would be 1, 2 would be 4, and 3 would be 9. This is the parent quadratic function and the shape of the curve is called parabola. The shape of this curve is called parabola. Identify any maxima or minima. The point is called the vertex of the parabola. Maximum and the minimum would be 0, 0. So this is called vertex of the parabola. Draw a vertical line that goes through the vertex. This line is called axis of symmetry. Write an equation for the axis of symmetry. This line is called axis of symmetry, and the equation of axis of symmetry is x is equal to 0 because all the x values are zeros over here. Should there be arrows on the ends of the parabola? If so, add them. Yes, there should be arrows because it's keep on moving on. State the domain f of x is equal to x square. What will be the domain? We can put any value, so it would be minus infinity to plus infinity. What will be the range? Range will be, because it's the x square function, values can always be positive, it can never be negative. If f of x is equal to x square is a one-to-one function, one-to-one, no, it's not one-to-one function because it fails horizontal line test. Transforming quadratic functions. A quadratic function containing x square is the highest power term in its equation, and it has a graph in the shape of the parabola. So f of x is equal to x square has a graph of the parabola and the highest power is square. Quadratic functions may open upwards or downwards, may vary in the width or steepness. They can also be shifted left, right, down, or up. The function f of x is transformed to create a function g of x. So this was f of x, it was transformed to create g of x as shown in the graph below. Describe the transformation from the map from f of x to g of x. So what's happening here? It's reflecting over x-axis. And it's moving towards right by 1, 2, 3. Use y is equal to a f x minus h plus k to write the equation for g of x in terms of f of x. So g of x would be equal to negative of, because it's reflecting towards f and x minus g. If f of x is equal to x square, write an equation of g of x in terms of x square would be minus x minus 3 square. The graph f of x is equal to x square has been transformed to create several new graphs shown below. Write the equation in terms of x square for each graph. Be sure to incorporate all dilations, reflections, and translations. So basically it was few things has been just one of the table is I think missing over here. Yes. Okay, so this is y is equal to x square and it's minus 5 down, so it's going to be y is equal to x square minus 5. So it's same but it's downstairs, so y is equal to minus x square. Y is equal to x is expanding here in this function, so it's minus x square because it's opposite, and going upwards 5 times, so plus 5. So it's going to be x minus 3 whole square because shifting towards left. This is x is going 1 2 x plus 2 whole square and down plus minus 1 going down, so it's going to be minus 1. X square and divided by 2. It's x plus 4 something x plus 4 square. It's negative x 1 2 3 x minus 3 square plus 5. Vertex form of a quadratic when y is equal to a x minus h whole square plus k, where a, h and k be help to identify the transformation from the parent function. So sketch the graph of y is equal to 1 by 2 x plus 3 whole square minus 4. So what these points represents? A represents shape, h and k means vertex, and x is equal to h is asymptotes. So we have y is equal to 1 by 2 x plus 3 whole square minus 4. So let's say a is equal to shape, a is equal to 1 by 2, h and k will be equal to 3 and 4. But first we need to change the equation. According to this, y is equal to 1 by 2 x minus h whole square plus k, x minus h whole square plus k. So now hk would be equal to minus 3 minus 4. So what is the vertex? Minus 3 minus 4. So x is equal to h is AOS. So what is x? X is equal to h. So what is h? Is minus 3. So what is domain? Domain, the graph is going to go from and range in y-intercept. So let's plot the graph. Okay, for minus 5, x is equal to minus 5. Minus 5 plus 3 is equal to minus 2 square is equal to plus 4 by 2 is equal to 2 times 2 is 4 and minus 2. And here we get minus 4, here we get minus 2. So let's plot minus 5 and minus 2, minus 3 and minus 4, minus 1 and minus 2. So we get the 3 points, this and this, because we know quadratic function has the shape of the parabola. Okay, so what will be the domain of this? It is going from minus infinity to plus infinity values of x, and values of y, it is a range. It is going from maximum minus 4 to the positive infinity. And y-intercepts, it is crossing y at 0 from here zero and 0.5. We can also find y-intercept by putting x0, which will be equal to 1 by 2, 0 plus 3 whole square minus 4, 1 by 2, 9 minus 4, which will be equal to 0.5. Sketch the graph of y is equal to this. So vertex would be, okay, first of all we need to change y is equal to a x minus h whole square plus k. So h and k would be 6 and 0. The vertex would be 6 and 0, and the value of h is 6, so AOS will be 6. Okay, now about the domain, let's plot x and y values. Okay, 4, 5, 6, 7, 8, and we will get minus 8, minus 2, 0, minus 2, minus 8, 4 and negative of 8, 5 and negative of 2, 6 and 0, 7 and minus 2, 8 and minus 8. So domain is going to be minus infinity to plus infinity, and range is going to be y values are minus infinity to negative infinity to 0. Y-intercept, to find the y-intercept, put x is equal to 0, minus 72. So y-intercept be x would be 0 and y would be minus 72. Write the equation in vertex form of the parabola graphed below. Vertex is this, that is 2 and 8. So vertex is 2 and 8. So the equation is basically y is equal to a x minus h whole square plus k, where h is 2 and k is this. And what is a? A is basically the shape, and shape is basically representing, we need to find out the shape. And what is y? Let's take 1.64. Okay, so now we have the point 4 is equal to a x x is 6 minus 2 whole square plus 8. 4 is equal to a 4 square plus 8. 4 minus 8 divided by 16 is equal to a, minus 8 by 16 is equal to a, minus 1 by 2 is equal to a. So we get the value of 8, it is minus 4 minus 8 is 4, minus 1 by 4. So we can write the equation as y is equal to minus 1 by 4 x minus 2 whole square plus 8. Solving quadratic using square roots. To find x-intercept, also called the zeros or roots of the equation. What are the zeros or roots of the equation? The x-intercepts for a quadratic function. We substitute y is equal to 0 into the equation and then algebraically solve for x. When algebraic approaches, we choose square roots, factoring, and quadratic form. Will depend on the question. When a quadratic is written in vertex form, best approach is to use square roots. Algebraically solve for x-intercepts. For whenever we have to find the x-intercept, we need to put y as 0. So we got the two values of x, that is 3 and 7. Okay, so I'll solve for x-intercept when I'm going to put the y is equal to 0. So because it is square root of a negative number, so we cannot take a square root of a negative number, therefore no intercepts on the x-axis. Next is minus 0.1 or minus 5.9, approximately the two values of x. Okay, A manufacturer of tricycles find that the weekly revenue from tricycle sales is a function of the price of the tricycle P. A model for the weekly revenue is in dollars can be modeled by the following equation: R P is equal to minus 2P minus 50 whole square plus 5000. Sketch the graph of the revenues vertex versus tricycle price. What is the maximum revenue from tricycle prices? So what does this happening? What it will be the maximum revenue from the tricycle prices? For drawing the graph, we should know the a x minus h whole square plus k. So h and k would be 50 and 5000. So let's pause here. It is 50 and 5000 is here, 50 and 5000. So this is the vertex point, and a is negative 2, so it's going negative, so it's going in the opposite direction and opening towards 2. Okay, so this is the graph. The maximum price of the remaining of the tricycles is $5,000. What should be the price of the tricycle in order to maximize revenue? $50. Determine the x-intercept. X-intercept, we need to put y0 is equal to minus 2p minus 50 whole square plus 5000. 2p minus 50 whole square is equal to 5000. P minus 50 whole square is equal to 2500. P minus 50 is equal to plus minus 50. So P will be equal to either 0 or 100. The revenue will be $0 if the tricycle costs $0 or $100. What is the practical domain for this model? So the domain is from 0 to 100, and the range for the model would be 0 to 5000. What should be the price of per tricycle for the revenue to be the least $1800 per week? So for $1800 we get the price. We will put the price 1800, which is equal to minus 2 p minus 50 whole square plus 5000. 2 p minus 50 whole square is equal to 5000 minus 1800. P minus 50 whole square is equal to 3200 divided by 2, which is equal to 1600. So taking square root on both sides, p minus 50 is equal to plus minus 40. P is equal to 10 or 90. What is the revenue if the price per tricycle is $70? So if we put R 70 means minus 270 minus 50 whole square plus 5000 minus 220 whole square plus 5000, which is equal to 4200. What other price will yield the same revenue in the part H? As here it was 50, here it is 30, here it is 70. So for 70 the revenue is this, and for the 30 the revenue is this. So for 70 and 30 the revenue is going to be same. Problem set number 2.1. Without actually graphing, predict the coordinates of the vertex, decide whether the graph would open up or down, and discuss how the shape would compare to the other parent function. So first of all, y is equal to minus x minus 7 whole square plus 6. So the vertex is going to be 7 and 6. So it's negative, therefore it's going to go downwards. Either it would be narrow or wider. neither. It would be -9, 0 upwards, and it's multiplying by 2, so it's going to be narrower. Okay, so it's 1 by 2, so it's going to be wider, and positive, so it's going to go upwards. Positive means upwards. I will write here. Positive means upward. Deviant means wider, and it would be 1 and 0. Okay. -1 by 3 x square means 0, 0. Negative means downwards. And wider. Okay, so it's going to be vertex is going to be -3 x square 0, 7, 0, 7. Negative means downwards, and multiply by 3 means narrower. Multiply by 5 means narrowards. Positive means upwards. And the vertex is going to be -3 and negative of it. Okay. Sketch the graph for each of the following quadrants. Use your understanding of the shape and direction of opening to help you add points in the graph. Include at least 3 points. Okay, so negative means downwards, so shape is going to be downwards. So first of all, the vertex is going to be x -0. It's going to be 0 and 5. The vertex is going to be 0, 5. So 0 on the x-axis, 5 on the y-axis. It's going to open downwards. So for f of 1, it's going to be -1 plus 5, which is equal to 4, 1, 4. For 2 is going to be -4 plus 5, 1. For 2, for x is equal to 1, y is 4. For x is equal to 2, y is 1. For negative values, -1 -1 square plus 5 -1 plus 5, 4. So -1, 4. So it's going to go like this. Okay, so vertex is going to be 5, 0. Positive means upwards. Multiply by 2 means it's 2 units narrower. Narrower, 2 units narrower. Okay. 5, 0, 1, 2 units narrower, and upward. Okay. Write an equation for the quadratic function that has a minimum at 3, -5 and passes to the point 1, 2. So if it has minimum at 3 minus 5, so the vertex is at 3 minus 5. But equation of quadratic function, so y is equal to a x minus 3 whole square minus 5. Now point at 1 2. If it has 1 point at 1 2, so it would be 2 is equal to a 1 minus 3 whole square minus 5, 2 minus 2 whole square minus 5, 2 plus 5 is equal to a 4, 7 by 4 is equal to a. So the final equation is y is equal to 7 by 4 x minus 3 whole square minus 5. For each function, graph the and answer the questions that follow. So firstly we have x minus h 2 and negative 7 is the vertex, and h is equal to VS, which is 2. Domain is going to be, so nothing is multiplying with the x, so there would be no positive means upwards and neither narrow nor down, so 2 minus 7. Domain is going to be minus infinity to plus infinity. Range is going to be, y values are from minus 7 to positive infinity. Y intercept at and x intercept at. For to find the y intercept, we need y is equal to 0, x minus 2 whole square minus 7, x minus 2 whole square, square root of 7 is equal to x minus 2, square root of 7 plus 2 is equal to x, x is equal to 2 plus minus square root 7. Okay, for this minus 2 minus 6 h minus 2. Now 1 by 2 means wider and positive means upward, wider and upward, so minus 2 minus 6. Domain is minus infinity to plus infinity. Range is minus 6 to positive infinity. Y intercept, okay. Let's find y-intercept over here. And 0 is equal to 1 by 2 x plus 2 whole square minus 6. 6 is equal to 1 by 2 x plus 2 whole square. 12 is equal to x plus 2 whole square. Square root of 12 minus 2 plus minus is equal to x minus 2 plus minus square root of 12. It's minus 1 and 2. It means it's going to be narrow. Negative means it's going to be downwards. So minus 1 and 2. Range is going to be ranges to negative infinity to 2 and 0 is equal to minus 3 x plus 1 square plus 2. Negative 2 is equal to negative 3 x plus 1 whole square. Negative 2 by negative 3 x plus 1 whole square. 2 by 3 square root is equal to x plus 1. Square root 2 by 3 minus 1 is equal to x. Determine an equation for each of the following parabolic graphs. Vertex x minus 4. So we have y is equal to a x minus h whole square plus k. So we get the values of minus, and then minus 6, it will become plus 6 whole square and minus 4. It's x. And what about a? It's going to be upward, so positive and just positive. So y is equal to a means downward, so negative. X minus 0 whole square is equal to x square minus 4 plus 4. Downwards is going to be negative. X minus 5 whole square plus 9, and it's narrower. Down it's 3. 1 and 1. Here it's 1. Here it's 1. Three minus 4. 3 minus 4 means x minus 3 minus 4. Upward means positive. 1/2 voided. And we need to calculate the a by taking any one point. Okay, we can also do this by taking any one point. We can calculate a because a is always not sure. So we can do is taking a point this point. This is 1 minus 2. So y is equal to a x minus h whole square plus k. So it's going to be minus 2a 1 minus 3 whole square minus 4. So we get a is equal to 1/2. Here if we take any one point, example this, or this is 4 from the x-axis, 4 and 6. It would be 6 is equal to a 4 minus 5 whole square plus 9. Okay, 5 is equal to ax In this way, we can calculate a by taking any one point on the graph. Write an equation with a quadratic function with f minus 1 is equal to minus 7 and maximum at 2 minus 1. So the vertex is at 2, 2 minus 1. And f of minus 1 is f of x is minus 1 and y is 7. So we get 1 point. We can find a minus 7 is equal to a x is minus 1 minus 2 whole square minus 1. Y is equal to minus 2 by 3 x minus 2 whole square minus 1. Done with it. How many pages are left? Okay. Algebraically solve for the x-intercepts for each of the parabola. So to find the x-intercept, you know what we need to do. We just need to put the y is equal to 0. So 0 is equal to minus 1/4 x minus 1 whole square plus 4. Minus 4 is equal to minus 1/4 x minus 1 whole square. Minus 4 into 4 is 16 and plus square root is equal to x minus 1, 4 plus minus plus 1 is equal to x, so x would be equal to minus 3 and 5. 0 is equal to 1 by 3 x plus 4 whole square. 0 is equal to x plus 4 whole square. Vertex will be minus 4 and 0, and vertex is in middle. So x would be minus 1 and 5. Okay, 0 is equal to minus x minus 7 whole square plus 6 minus 6 minus x minus 7 whole square plus minus square root 6 plus 7 is equal to x. So no x-intercepts as the square root of the negative number do not exist. A golf ball is dropped from the top of the Paragon building. The ball's height in meters can be modeled using the equation h of t is equal to minus 5t square plus 130, where t represents time in seconds after the ball has been released. Sketch the graph of the height versus time of the goal graft. So it's going to be time and the height. So for the y-intercepts and x-intercepts, so 0 is equal to minus 5t square plus 130 minus 130 by minus 5. So it's going to be square root 26 and 0. Square root 26 and 0. And for the y is equal to 0 plus 130. So it's going to be 0 and 130 like this. How high is the Paragon building? So it's 130 feet height. Determine h2, give a real world meaning for this. h2 is equal to minus 5 2 square plus 130, which means 110 feet. How long until the ball is 50 meters from the ground? 50 is equal to minus 5t square plus 130. 5t square is equal to 80. T square is equal to 16. T is equal to plus minus 4. Time is positive, so t is equal to 4 seconds. When does the ball hit the ground? When? So means h is going to be 0 because it's going to hit the ground, so height is going to be 0 minus 5t square plus 130. 5t square is equal to 130. T is equal to plus minus square root 26. So it's going to hit the ground after 5.1 seconds. When a ball is going to hit the ground, the height is going to be 0. What is the practical domain for this model? From 0 to square root 26. So we are done with the unit 1, and we have learned how the quadratic functions behave and how we can solve the vertex form of a quadratic function.